Okay, I do want to go ahead and restate something. So based on good question, Tarana, about who the customer will be, want to restate something. So as far as the customer you will be submitting your initial design to, that's going to be me. Okay. Now, there are aspects of it that because I am a one person, I won't act as a full-on customer that you would constantly be in communication with over and over again. We will talk through a little bit about what the initial requirements will be for everyone. Where what you'll need to do is basically go out and kind of do some research, do some fact finding to figure out what your system should look like, what type of columns you should need, what kind of data points you should consider, things like that. That you'll need to go out and do that on your own, and I won't be personally involved in a lot of those discussions. But as far as the first submission, the initial design that you're going to submit that through the Microsoft Teams to me, and then I will come back to you with points to consider, some comments, and some requests. Okay, and that's where I will be the customer. Okay, and then of course, as in the real world, as in a if you are working for a real world company, when you submit your final product, the customer gets to be the final decider of whether or not you satisfied their requests. Okay. There will also be an aspect of it where each of you will be also rating and evaluating the others group projects as well. Okay, so don't think that the only part of this grade is going to be how well you designed your product. It's also going to be your ability to evaluate other people's products. Okay. All right. Back to our slides here. Let's see. Okay. So there's some other aspects of database design. The actual design of the database itself. So up here we were talking about how to requirements collection and analysis of how to collect our requirements into some type of database design. But the question is how do we get from here, from requirements, to here, to the ER model? Or, again, from here, requirements, to here, a partial ER model. Right? Well, we'll need to figure out how we want to design our database. We can do this multiple different ways. So you can do top down, bottom up, inside out, mixed. So the top down approach starts with the highest level and moves down into the subcomponents. So you would start with things like parent tables. Like I want to create a parent table would be a department, like faculty at a university. And I'm going to take that department and say, okay, I'm going to create the design for the department part of this, and then I'm going to come down to create the teacher table, for example. And teachers can be part of departments. That would be kind of the top down. The bottom up would go the other way. We would start at the smaller child components and put them together. Okay. We want to build a data model. One of the things that we'll talk about is ER model, entity relationship model, that will help us understand how the meaning of the data, like how does it look, how does it work, how does it relate, how do different objects relate to each other, right? To understand the communication about the requirements. One of the nice things about modeling is that it's something that a lot of people can understand, even if they don't understand the technology aspects of things. So as programmers, we like to use models because we can take those models and write code off of it or create database tables, in this case, off of it. Our users and our customers like models because it's something visual and they can kind of understand how things work together without necessarily needing to know SQL or Java or whatever. Okay. And we can help ourselves understand how the users will interact with the data, what is the use of data across the views, and what is the nature of the data. Again, an ER model will help us in database design the same way that a UML model would help us in developing an object-oriented system in Java, right? So, and I say in Java because that's what we teach here, but what I mean is, just like we talked about in the 101 and 102 courses, I can take a UML model and create code in multiple different languages, Java, Python, other C#, other object-oriented languages. And in the same way, I can take an ER model that we're going to create, and I could create a database in a MySQL. I could create an Oracle database. It's independent of the specific technology that I'm using. Okay. All right. So I'll skip over this, but just an idea of criteria to create an ideal data model. All right. Each of these, conceptual, logical, physical, we will spend across 2 weeks at the end of the semester. We will cover these three more in depth, but kind of an overview of the three topics here. The conceptual is we are creating a model that's independent of any physical consideration. So it doesn't matter what servers we need. It doesn't matter what database management system we're going to use. Basically, we are focused on trying to take the user's requirements, our customers' requirements, and build a model that looks like what they want, okay, or looks like what they need. I shouldn't say what they want, what they need. Sometimes the job of a good programmer is to understand our customers' needs and know that that doesn't always line up with their wants. Okay, there is a big difference. Okay, so for each of these phases, for the conceptual, logical, and physical, the output of one phase is the input to the next phase. Okay. All right. So we're going to take the output of the conceptual phase, which we'll talk about, is going to be an ER model, and we're going to use that as input to the logical phase, which comes next. Okay. So we're going to take our ER model, and we're going to construct a data dictionary, basically a data model. Right, off of that. And now we're going to get more into some of the, I want to say nuts and bolts. We're going to get more into the specifics of requirements. I'm sorry, of what's the word? I want to say restrictions, but that's not right. Constraints. All right, like our integrity constraints and our referential constraints and stuff like that. We'll start considering what some of the general constraints of different data can be. Okay, and that's what this is going to be. Now again, we are not at all considering which DBMS we're using. That comes in the final phase. All right. And in the final phase, we will get into a physical database design. And again, this is still a design. This isn't, I mean, once we get done with the physical database design, we should be able to just map that directly onto some database server or to some other physical technology. But this is now where we're saying, okay, we're getting into the actual how to create the tables, indexes, columns, all that stuff, okay? How the structure of the database is actually going to be done. And the reason why we wait till here for a lot of this is because based on which technology we choose, based on which DBMS we choose, may determine what we can and cannot do with some of these things. Okay. Again, as usual, I like to have a visual for these things. Okay. So we have kind of a logical conceptual, the idea of what is a conceptual schema, what's the idea of what we're trying to do. An internal schema would be part of how it's designed, how it's defined, and then physical storage would be the actual server itself, the actual, because remember, all this is going to go onto some computer somewhere, right? All stored somewhere. Okay. I'm not going to go into this too much, the DBMS. I think most of you probably already know which DBMS you're going to use. Sometimes we do this before. Sometimes we select our DBMS even before we start designing anything. But oftentimes, if we've done things well, we want to design our database first and design what we want our system first, and then determine what language or what DBMS we want to do. Just like if we were designing a user interface system, we might want to design the system itself first and then determine whether or not we want this in Java or Python or some other language, right? And in fact, I know of, I wish I could remember the name of the company right now, but I met someone just a couple of years ago who their company actually created their own DBMS because they found that the existing solutions, the Oracle, MySQL, and all of those, did not satisfy their requirements to a level that they were acceptable to them. And so they designed their own DBMS for use within their company. All right, so sometimes after we're done designing our database, we find that nothing that exists is good enough for us, and we may end up needing to design our own. Right? That's pretty rare, I would imagine, but it does happen. So you might have some list of features, right, that you want. Right, so this is, I'm just going to cycle through these pretty quick, but these slides are available so you could look at them. But just basically what we're going to do is we're going to say, okay, we have a sample DBMS, and there's basically the idea is, okay, how good is it at doing this, right? Right. Some comments of why it is, whatever, but we're going to give it a rating, and we're going to say, you know, this is high, this is really good, this is not so good, this is really bad, right? But the weighting part would be, okay, how important is that to us? Because the thing is, you may have one DBMS that does something really good, but it's not really important to us that it does that. You might have another DBMS that does whatever it is poorly, like does not provide it really at all, but it's not really important to us. So as we take what's most important and we say, what do I absolutely need to have? Yeah. And then we make our decision based on what's important, not just on, we don't just say good, 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 therefore I'm going to choose that one. We say, okay, good at what I really need, I need to choose that one. Not so good at things that I don't really need, okay, I'm okay with that. All right. Okay, so that's kind of how we would analyze even the DBMS for choice there. Again, I don't want to focus too heavily on application design but I do want you to at least be aware that the design of an application is important. Okay. We do need to understand that we will have a user interface that interacts with our database. Okay. So we talked about transactions, that we should be able to have a user interface that can send queries to the database. Okay. All right. So we talked about that. We'll talk about prototyping more in depth later. Okay, but the idea is actually, hold on just a second. I need to take a break. 1 second. Okay, so I realized that for the prototyping, I think I want to go ahead and have this discussion here instead. So, all right. So the idea is if we have a system, let's say this is our system. And this is the entire thing that we want to create, okay? This big box, right? Now, the system may be divided into different parts, like maybe user interface, all right? And we might have our database, right? And we might have financial stuff. I don't know. Maybe it connects to something else. I don't know. Right. We might have this other part. Let's call it security because that's always important. Okay. So let's say that we have this. This is our entire system kind of all put together. Right. Now, prototyping, we can do a couple of different ways. Probably the most common are the two that I'm going to talk about now. One would be a very shallow prototype. And what that means is we take just one sliver of each part, right? And we build it. So we take one part of the GUI, or one part of the system. Let's say maybe if we were doing like a Sahib and Den, we might do all apartments because Sahib and Den does apartments and houses and cars and other things as well. All right, so we might just take one little part. We'll say, you know, the apartments for Sahib and Den, and we fully develop the user interface. the database, maybe the financial aspect, the financial security, and the security aspect for all apartments to show our customer, hey, we can do this. Right now, we haven't done this for cars or, you know, whatever else down over here. All right. But we are able to do that for one part of the system. And actually, I think this would be considered a deep thing because we've done everything for one part of the system. Okay. So if the customer comes in and says, well, wait, what about cars? Well, we're not showing you the cars part. We're showing you that we've developed this all out. We've used some time to develop completely one part of our system to show you that we can do this for all the other parts. Okay. Another way that we could do prototyping, though, would be this other way. So you take, I'm going to take the database part and do a different color. All right. And we say, I'm going to fully develop the database for all the parts of the system. Okay. Not developing a user interface, not developing any of this other stuff, right? I am just going to focus on one part here for the entire system. And then that way, if the customer says, well, but we'd like to, if the customer would like to see a user interface demonstration, you know, then this format might be a better way to prototype. If the customer would say, but I really want to see how you're going to work across, because different parts of our system are very different. We treat apartments very different than cars, they're very different from other things. Then you might want to pick one part of the system and develop it out completely. Okay, but the idea is that we do a small portion, some small portion of the system to give evidence to our customer that we can do the rest in the same way. Okay, again, just as I've said before, neither of these is better than the other. It just depends on what type of system, what type of thing you're dealing with. Okay. All right. Back to my slides. So that's how prototyping works. And then we'll need to implement our database. We'll need to actually use a DDL and a SQL or whatever to create all of our stuff, create all of our structures, our tables, and all that stuff, and our views. Right? We may need to do data conversion. Again, as you guys have heard me often say, one of my first jobs was with a company that their job was data conversion. We had to take, my job was data conversion. I had to take data from an existing format, spreadsheets, Microsoft Access databases, Notepad documents. Didn't have any handwritten stuff. That was good. That was good. There was no handwritten anything, but I had to take it and use scripts to convert it into our format. This is oftentimes not a short process, right? Because especially if the existing format is very different, like Notepad, for example, it can cause a lot of problems. All right, it can take a lot of time. Okay. One second to last, I think, thing that main topic we'll talk about here on this set of slides, testing, oftentimes is one of the last things that we think about, but really should be one of the first things that we think about. All right, testing is very, very important. In fact, I teach an entire graduate class that focuses on software quality assurance, of which testing is part of that. One important thing that we need to remember about testing is that we cannot show that a system works. Testing can only show that a system doesn't work. All right, it doesn't prove that a system works, but it can show us places where a system doesn't work. Right? And the reason why I point that out is because a lot of times people think, oh, my code works because it passed all of my tests. A lot of our first year students do this. A lot of our first year students, they submit their assignment code. Their grade is not what they expect it to be. And they say, but it worked on my computer. It worked great on my computer. And the truth is, yes, that's because it passed your test cases, but it didn't pass ours. Right? So your code, so the problem could have been that your tests were not enough to show all the faults. Right? Testing cannot prove that something works. In the same way, if we think about it from a right now, we have over the past year, a lot of people have gotten tests for the COVID virus, right? And a test cannot prove like that a population is healthy. It can show where there are people who are not healthy. And what I mean by that is, let's say you have here in Antalya, we have what is it, like 2 million, 2.5 million people. If 100 people are tested for the virus and none of them have it, they all come back negative for the virus, does that mean that there is no COVID virus in Antalya? And I hope that all of you on the other side of your computers right now are saying, well, of course not. There could be, 2 million people with the virus. We maybe just tested 100 people that happened to not have it. Right? Right. And so the only thing we know for certain after that is that those 100 people don't have the virus. We don't know anything about the other 2 million people. All right. And so that's why we need to test thoroughly. We need to create test cases that do a good job of testing thoroughly. Now, that doesn't mean, so I'm sure some of you would say, well, wait a second. Joseph Hoja, are you suggesting that we should go out and test, go out to their houses and go out to everywhere and test all 2 million people to see if they have the virus before we know that no one has the virus or know who all has the virus? And the answer to that is no, that would not be feasible, right? And in the same way, testing software, we cannot test every possible input to a system for every possible output. But we can be smart about how we do our testing. We can say, I want to make sure that I have a good, solid number of test cases for this part of the system, for a certain part of the system. So in the same way, what you might do with a place like Antalya is you might say, okay, well, we are going to make sure that from, places that have a lot of people, we're going to get a higher number of participants to test for the virus, and maybe in more sparse areas, rural areas, village areas, we might say, let's just get a couple of people from there and test them to see if they have it, right? And that might be a smarter way to do testing, right? And I don't know, because I'm not a medical expert, so therefore I don't know the best way to do testing for the virus, right? But I do know that it would not be possible to go around testing every single person in an area. Okay? And in the same way, it's not possible to test a software system for every possible input to check every possible output. Right? But what we can do, again, is be smart about how we test. And this is kind of an area that I like to talk about, so I spend a lot of time talking about it. I'll go ahead and move on because many of you probably don't want to hear me ramble on about this. But if you're interested in testing, it's something that I'll say it again. It is one of the first things that get cut when time is of the essence, when we have a deadline approaching and we have to get things out. Testing is one of the first things to get cut, but it is probably one of the most important parts of a software development lifecycle. In fact, how you can tell when testing was not thoroughly done, anytime, I would say almost any time that you get a patch pushed to your computer, if you're running a Windows computer or a MacBook, I think Linux probably doesn't do this as much. I don't use Linux a whole lot, but I don't think Linux does this as much because it's open source. But with Microsoft and Apple, anytime that you get a patch pushed to your system, not a new update, not a new update to the operating system, but a patch to fix a problem, it's because they didn't test something. It went out to the real world. It went out to customers. Customers started experiencing problems and reported them. And so if testing had been done well, we would have fewer patches. Okay, but testing is one of those things that's kind of like, oh yeah, we should probably test things, but it needs to be more focused. All right. Okay, so another slide on testing, but I'm not going to go into that in too deep. Operational maintenance is what happens after a database system, or any system for that matter, has been pushed out to production, what we call production. It's basically, it's out there, it's being used, but that doesn't mean that it's perfect, right? And things change. The reason we need to monitor the performance of a system is we built our system around a set of example data, right? We built our system using, and it could have been existing real data that the company provided, that our customer provided, right? But it was example data. It wasn't the same data that would exist for all time. And our performance tests were based on that data at that time. Maybe over time, data changes. Maybe for example, certain aspects of data, birth dates or other columns that we've put indexes on to make them faster, now have become slower because the nature of the data has changed, right? And so as we monitor the performance, we look for bottlenecks, we look for places where the communication with the database server slows down, and we tweak and we change our system a little bit over time to make sure that it keeps up with what our needs are. Okay. All right. Some new requirements may come into our database application. We've talked about before, earlier in this lesson, we've talked about the mission statements of Google and Amazon. I know what Amazon's mission statement is today because we just looked it up. I don't know what Amazon's mission statement was 20 years ago. Maybe we should go look that up at some point. But I imagine that their mission statement has changed a little bit over time. But over those past 20 years, new requirements have come to Amazon. I mean, I think 20 years ago, Amazon was just a place that I could order books from. That was all they were doing, 20 plus years ago. All right. But now they're doing a lot more. So they've had a lot more requirements into all of their systems, including their database applications. All right. So we need to incorporate those new requirements. We can computer-aided tools, right? We can use them to help facilitate, to make things easier for ourselves. All right. Let's see. We'll have what we call the uppercase and lowercase, basically the computer aided software engineering tools. I think that's what computer aided. Yeah. You can use them for different purposes, right? Especially down here again. I don't want to spend too much time on this whole idea that the testing stuff, but automated testing. My first job, part of the reason why I focus on testing is my first job in software development was as a software tester. I actually did not have a background in software development. My undergraduate degree was electrical engineering, and I was hired, and then my master's degree was electrical as well, and it's computer. No, don't worry about it. And I was hired because I was hired to basically do a form of what's called black box testing, meaning I was not a software developer. Therefore, I would not know a whole lot about how the software was supposed to run, so I could test it the same way that a real user would. And that was what they were lacking. The company was lacking the ability to think like a user, right? And so I was hired to do that testing. Well, you know, the way that I approached my testing, because I didn't even have a history of testing either, but the way I approached testing was I would pull up the program and I would say, I think I'll test this page today. And I would start typing stuff in, click submit, type this, click, and I would just keep it in an Excel spreadsheet. Okay, this is what I tested. This is what happened. This is what I tested. This is what happened. You know, I realized pretty quickly that that was not working very well for me. There was no systematic approach to testing. It was just kind of like, let's just test something. That looks good. I'll test that. Right. What I learned quickly was having some type of structure, some type of systematic approach to the testing would really help me a lot. Right. And so I started doing that, and I still kept my Excel spreadsheet, but I also said, okay, we're going to test this, and then I'm going to analyze the page because it was a web-based product. I'm going to analyze the page to determine what needs to be tested on that page. I'm going to list those out and all this. So I had a systematic approach, but then later what we got was what's called, I can't remember what the tool was called. It's a long time ago. This was a long time ago. But an automated testing suite. And what would happen is I could develop my test cases, and I could say, this is what needs to be typed into this field. This is what needs to be typed. This is what needs to happen. And I could click run, and it would run multiple tests all at once, and it would tell me which ones passed and which ones failed. Right? And that would be considered what a case tool would be. This tool that could run an automated testing, some type of automated testing suite. For the prototyping, some of you may remember, some of you may be able to help me out with the name of this. I don't know the name of the tool that some of you use, but like for me, if I was doing prototyping right now, the only tool that I could even think of would be, maybe, I don't know, throw in Microsoft Paint and draw stuff out by hand, right? But some of you I know have used, there's a tool where you can like set up the windows and put the fields and the buttons on them and stuff like that. And it's not an actual user interface. It's just kind of a grid design that does it. I can't remember the name of the tool, but it's kind of like a gray, black and white, where you put the window and say, this is the screen and this is the buttons and stuff like that. But that would be an example of a case tool that helps with prototyping. All right. So, finding out what's out there, using the tools that are available to us, that's a good thing. All right. There's a slight difference between the data administrator and the database administrator. These are two roles that exist in a lot of organizations. I would say if you have space for one of these, you're probably going to have something called a database administrator that also does the data administrating as well, administering role. But in my experience, I've never worked on a project that had a data administrator, but they do exist, especially for much larger organizations. Database administrator, however, is someone who's responsible for managing the database themselves. For anybody who really is loving this database stuff, that's really loving working with databases. A database administrator is an important job, right? And they are going to be in charge of making sure that the database itself runs smoothly. Okay. Database administrators are they're going to be monitoring the database to make sure that there's not a lot of bottlenecks, that things are not. They're going to be running scripts. They're going to be snooping. No, what is it? Can't think of the word. Where they monitor the network traffic between the system and the database to make sure that things are running as fast as they can. Right? And when they find something that slows it down, they'll notify the programmers, and we'll try to develop a solution of some kind. They'll be in charge of they'll be in charge of applying indexes to tables. We'll talk about what an index is later. But they'll be in charge of modifying the structures to make sure that things run as smoothly and as quickly as possible. All right. Again, so data administration is going to be concerned about the data itself, about the database planning, some standards, policies, and procedures. All right. And then again, our database administrator is going to be concerned with the physical design and implementing. And this is probably why this is the only one I've ever encountered, is because every project I've ever worked on was an existing project that's been around a while. So could be why the only people I ever encountered were database administrators. Yeah. So good job, pays well, important, but also a lot of work. Right? The database administrator is going to be a very important role that takes a lot of time and a lot of energy to be able to do. But it's good work if you really love database stuff. Okay. All right. So that's it for database development. Do we have any questions about what we've talked about today? Again, I know it seems like a lot. I know we went through a lot. It's because we introduced a lot of concepts today. We introduced a ton of stuff today from kind of a high level overall view. And then in the next weeks, we're going to go down into those topics to really talk about them more specifically. But I wanted to introduce you to some terms that that will come up in the future, so that now that you have those terms, we can kind of focus on what do they mean now. All right. Are there any questions about what we talked about today?
Can I ask a question?
Of course.
So these topics are more theoretical, right? Like they are not practical ones, as I understood.
Well, they are practical in the sense that when I say overall, it's like it would be like if I was giving a math class and I said, basic arithmetic is addition, subtraction, multiplication, division, and I kind of introduced those terms to you. And then the next time I came back and said, okay, now let's talk about what addition is, and then we kind of focus on addition itself. And I think that's what I mean by we're doing an overall view here now, is that, so for example, one of the early things we talked about, like requirements collection and analysis, for example. We kind of introduced that topic and we kind of said, okay, this is kind of how you would do that. Now, in the future weeks, we're going to talk about how do you actually collect requirements, because there's going to be a set of slides coming up. Let me take a look. I think it's going to be next week, actually, in the database analysis section, where we'll talk about the different fact-finding techniques of how you get those requirements and how you get information about the system you're trying to develop. right? And yes, as far as how these things are done, some of this information is older, and technology changes very rapidly, as you guys probably all know. In fact, I often tell my friends, this thing here, right? I have a smartphone. There's more computing power in this phone than there was in the entire space shuttle that brought human beings to the moon for the first time, right? So technology is constantly evolving and constantly advancing at a high pace. If any of you know Moore's law, maybe I'll bring that up as a quote next week. But Moore's law about technology and how fast it advances. So some of the stuff that we introduce here is just kind of foundational topics that have grown in recent years. Yeah, so it is older stuff. Good. Any other questions? Good. Okay. Well, thank you guys for another discussion. And man, I really miss being in the classroom with you guys. But hopefully we'll get through this pandemic together and get to the other side. All right. Have a good afternoon, and I will see you in a week.